Hi Math 20, welcome back. Okay, so the last lesson was all looking at compound interest. So we're just going to be working through compound interest problems. It's mostly going to just be about rearranging the formula to come up with different parts of the answer, but we'll also take a look at the rule of 72 and how that can come into play. So, all right, let's just jump right in. Let's get started. Calculate, same beginning as always, calculate to 2 decimal point. You try these. So go ahead and work this through. Again, the main focus is order of operations. Really important, especially as we get into these harder problems. You can do that. So please work these through. You should come up with 341.51 and 907.03. All right, the first one here, we've got a cashier at a wallpaper store in Calgary. She invests into a savings account each month. So her interest rate, here's your interest rate, and how many times it's compounded annually. So you know once a year. After 2 years, one of her monthly investments was worth $97.49. So how much did she invest? This time you know what the investment was worth. So you've got your you've got that part of your equation, the amount, but you don't know what she started with. So you don't know your principal. So you're trying to solve for P. So here's your interest formula, A. You have interest and you have what you don't have is P. This is what we're trying to solve this time. So fill in what you can get so far. So 97.49. We have that. We're trying to solve for P. 1 plus what was our interest? 1.3%. So 0.013. Compounded annually for 2 years. So that, because it's compounded annually, remember from the last one, it was over. In this case, because it's compounded annually, it's technically over 1 and then times 1 here. So they just don't put it into the formula when it's compounded annually. You don't have to. It cancels. It's a 1. All right. So how much did she invest that month? Let's solve this through now. So 97.49. Everything in your brackets. So 1 plus 0.013, and then that would have been squared. So that would become 1.026. It's got a lot more to it. Remember, keep that in your calculator. And now we have to get P by itself. So we divide this side by the 1.026. We have to do the same thing to the other side. So 97.49 divided 1.026 equals P. So P is going to be 95.003. It's got a bit more, but we can already tell that rounds down. So she invested $95 that month. So that was it. It was just figuring out what you have and rearranging your formula to get what you need. So let's take a look at this first example here. So she wants to start saving for a party business. Start saving for a party for her business in 5 years. The interest rate of her investment is 3.2% per year. That interest is compounded annually. How much does she need to invest to have $4,000 after 5 years? So she knows how much she wants to have. She wants to have A to equal $4,000. You have your interest rate was 3.2% or 0.032. The number of compounding periods in this case, because it was 5 years compounded annually. So it's 5 years compounded once per year, 5. So the number of compound periods is 5. So let's just put what we have now into our formula. So A, what she wants to have $4,000. 1 plus what her interest rate is, 0.032, and it's compounded annually, so that's over 1, times the number of compound periods in total is 5. So $4,000. You'd go 1 plus that to the power of 5. So you should come up with, make sure that you're doing this along with it, 1.170, and then just get P by itself. So 4,000 divided by 1.170. So you should come up with an answer of $3,417.13. So she wants to have $4,000. She needs, in 5 years, she has to put in $3,417 now. Let's see. Suppose you know the interest. Okay, so the rule is 72 now. If you know the interest rate in a compound period for an investment, which is what we knew before, we had the interest rate and the compound period. So you can use this rule of 72 to estimate how long it'll take for an investment to double. So the rule of 72 is really simple. The years to double is 72 over your annual interest rate as a percentage. So let's look at this as an example. James runs his own business as a locksmith. He is responsible for saving in his retirement, so he's investing in RSPs, which is something that, good idea to look at as soon as you're able to start investing for retirement. Because let's take a look why. So 1 year he invested $3,000 at 3.6% per year, and it compounded annually. So here's your key takeaways: 3,000, 3.6 compounded annually. How long is it going to take for his investment to double? So you have your interest is 3.6%. So the years to double is 32 over 72, over 3.6, 20 years. So it's going to take about 20 years, and his $3,000 turns into $6,000. So let's check that your estimate in Part A is reasonable. So we're just making sure the $3,000 at 0.036 compounded, and remember, compounded annually for 20 years, so compounded periods of 20. So the answer to this would be $6,085.78. So that is about double. So your estimate is true. Like it's a good estimate. Really interesting to be able to play with those numbers, because if you want to know, I don't know, maybe you want to retire as a millionaire. So you need to start investing. How long will it take to double your money? How much should you be putting in? This is super handy. So pay attention to this rule of 72, because it does come up in the mid-chapter review or chapter review. No, the chapter, yeah. We've done the mid-chapter review. It comes up in the chapter review, and it might come up in a test. So really important to remember as well. All right, so that's everything for compound interest problems. You can go ahead and do the work in the workbook after this. That was the end of this chapter. So you've got your chapter review and then your test. So if you have any trouble when you're doing your marking, any questions before you get to your test, please get a hold of me. Thanks for watching, and we'll see you in the next chapter.